Hello, everybody, and welcome to the Political Economy webinar from CEPR, which is organized by the Political Economy program and networks of in preventing conflict and in populism. We meet every Wednesday of the first Wednesday of every month at 3 p.m. London time. And so we'll meet again on the first Wednesday of April, where Roman Vaxiar is presenting. And then we have Claudia Ferraz in the first Wednesday of May. And then the first Wednesday of June, we have Liat Yarif from Princeton. And today we're very happy to have Nicola Persico presenting with us. And this meeting is recorded. Everybody should know that. And the rules of the game are, we have 60 minutes in which I'll moderate and interrupt Nicola for some questions that you can put on the chat. And then after the 60 minutes, there'll be 15 minutes just of questions that I will, that will mediate, and you can, speak yourself and ask the questions directly, but I'll just mediate that. So without further ado, I'll give the floor to Nicola. Thank you, Nicola, for agreeing to do this. I'm very excited to hear your talk.
Thank you, Elios. Thank you, Sergey and Ronnie, for inviting me. Let me share my screen now. You should see my screen shared. Is that the case? Yes, perfect. Thank you. So let me get going. This is a theory of non-democratic redistribution and public good provision. And let me go to the relevant talk here. So introduction. A core question in political economy is how political competition for votes shapes the allocation of resources. However, voting is not the only form of political activity. Politicians also compete for public endorsements, financial support, and activism, which may or may not be peaceful, and may include activism directed at replacing the incumbent by force, so something we might call protests or violence. Unlike voting, these forms of political activity are not anonymous. So citizens may be individually punished or rewarded for engaging in them. In this paper, I will give a model of resource allocation where political activity is individually incentivizable. So let me give an example what I mean. It's going to be like this. I, a politician, will promise you, a citizen, some future benefit, provided I will hold office and conditional on you having supported me politically. This is the nature of the promises in this paper. And these promises are different from the standard anonymous voting models. Why? Because of the last condition that you see written there. In traditional voting models, anonymous voting models, you cannot condition the delivery of a promise on individual political support because voting is anonymous. But here, political activity is observable and therefore contractable. The question is, how does political competition in this world where political activity is individually incentivizable, how does it shape the allocation of resources? In this presentation, resource allocation will mean how to divide a dollar. So it's a purely redistributive game. Richer policy spaces are available in the paper. Let me give you an intuition for how the game works, and then in the next slide for the main results. Because Ronnie told me that he doesn't have time to listen to the whole talk, so I need to be quick. So that's what I'm trying to do here. When political activity is individually incentivizable, as in this paper, citizens are trapped in a coordination game. Let me explain why. In this paper, each citizen will receive two competing promises from an incumbent and a challenger, but these promises are conditional on that citizen's individual support. The citizen will get a promise of alpha I from the incumbent, but if the citizen does not support the incumbent, the promise gets cut down to lambda times alpha I. and lambda is going to be less than 1. So you may think, and it's helpful to think for the purpose of this presentation, to wrap your head around this, lambda equal to 0. So if you think about lambda equals 0 for the whole presentation, you're doing good. So alpha versus lambda I, and from the challenger, omega versus lambda omega I. So less than the promise if you don't support the fellow. Okay, so that's a stipulation about how promises work. Now, an assumption about how individual political behavior matters. I'm going to assume that individually citizenized political behavior has no impact on who is in office. So it's an atomistic assumption. Because of this assumption, citizen I will not compare alpha I with omega I when choosing whom to support, but rather citizen I will seek to support the winner, or citizen I will try to avoid supporting the loser. Why? Because the only thing that the citizen can do with his or her individual action is to avoid paying the lambda. And so that's what the citizen is going to try to do. And this means that the citizen's job, main concern, is going to be to guess who the winner is going to be. And they're going to do this by using a precise signal about the incumbent's vulnerability. So I'm setting this up as a coordination game, as you can see. This game has the flavor of coordination because everybody is trying to guess who the winner is going to be and then to support that person. And that creates a coordination game. Now the core finding. How politicians compete to win the coordination game. First, in equilibrium, all citizens will coordinate perfectly almost always, either on the incumbent or the challenger. This is an artifact or a consequence of the way I'm going to set up this game. I'm going to set it up as a global game. And so this means perfect coordination. Okay. But now the core finding. To maximize the probability of winning the coordination game, the incumbent will make equal promises to all citizens. And the challenger will tend to do that too, unless the challenger is too disadvantaged. And I will be specific later, but what I want you to imagine or to think right now is that there's this tendency towards equal treatment. This result is not obvious. For example, in a democracy, we expect parties to favor core constituencies. So if we look at American politics today, some parties favor one class of people, other parties favor other classes of people. You don't see that kind of an equal treatment where a citizen receives the same promise from both parties. But in this game, they do. So I'll explain why this happens. Then I'm going to give some real world implication and then compare and contrast with anonymous voting. So that's the plan. And that is the end of the introduction. So at this point, you know more or less what's going to happen here in this paper. Okay, let me introduce the formal model now. The formal model has several pieces. First is the regime change rule. How
Nicola, just one question just to clarify. Suppose there's some models out there that have sometimes that people like to vote for the winner for some exogenous reason. Would that have the same implications? Is that an alternative interpretation?
Yeah, so I don't think so, because these models that you talk about, there's a lot of models that have certain features where people like to vote for the winner, where you get coordination and so on and so forth in politics. But these models do not talk about resource allocation. And so they don't connect with what does this imply with resource allocation? And that's the main contribution of this paper.
Okay. And then some in the chat, they're asking if you have some example, a real world example of what you mean by this competition with this lambda less than 1.
Oh yeah, absolutely. So what an example of a competition with lambda less than 1 is, suppose that you are back in 1917 or 1917 Russia, and there's a revolution coming, And so who are you going to support? If you support the czar and then the czar loses, then you're going to get punished economically, maybe worse even. So that would be an example where political activity, in that case, support in a civil war, is going to get punished. At a lower level, if you think about democratic systems, such as Italy, I'm going to say Italy not because I want to particularly talk about Italy, but just because I know it better, that if you are in high position, in a high administrative position, oftentimes you're attached to a party. And so what this means is that when the party is not in office, your career is going to be slowed down. So that would be another example of where individual political activity, in this case, a bureaucrat supporting a party, is going to get punished or rewarded. Thank you for the questions. Thank you, Elios, for conveying them to me. And I will now go forward. But I appreciate the questions, so keep them coming. Thank you. Okay, regime, let me set up the model. There's a mass one of identical citizens, and they're going to be indexed by I. And all citizens simultaneously choose an action, which I denote S for support. S stands for support, and S equal 1 means support the challenger, because it's an affirmative action to change the status quo. S equals 0 means support the incumbent. The incumbent is replaced if the share of support for the challenger is larger than an exogenous random variable. This is this equation you see there. The integral, which is the sum of all the support, if it's greater than something, that's the right-hand side, 1 minus theta. Think of that as something. That's a random variable. If the sum of these support is greater than something random, then the incumbent is replaced. Then the challenger is replaced. Sorry, the incumbent is replaced. What is the random variable? The random variable is random, and it's a indication of regime vulnerability. And there's some technical assumption about this random variable, which I take straight from global games. So just know that. The challenger will seek to maximize the probability that the S, this total support, capital S, is greater than the random variable, because the challenger wants to gain power. That's the only goal of the challenger. And the incumbent seeks to minimize the probability, because the goal of the incumbent is to keep power. All right. So in sum, S, capital S, is the spread of anti-incumbent activism, is how many people protest in the street. Theta represents the accidents of history that make the incumbent vulnerable in that particular moment. That I'm going to give specific examples as to what theta might be and what, etc. later. Now the policy space. As I said, this is a purely redistributive game. It's a divide the dollar game. So the constraint is that the sum of the alpha is equal to the sum of the omegas and is equal to B, constant. All right, now let me be more specific about the payoffs. And I have a payoff matrix here. And where I'm going with this is that I want you to look at the matrix and see a coordination game. Okay, that's what I'm leading up to. Okay, so what is the matrix? On the horizontal, on the rows, you have what the citizen's action, whether they support the challenger or the incumbent. And on the columns, you have the state of the world, whether the incumbent is replaced or the incumbent survives. And what are the payoffs? Let's look first at the second column, where the incumbent survives. In that case, again, in your mind's eye, please set lambda equal to 0. And then what do I have there? I have minus k if the incumbent supports the challenger, or alpha. Yeah, okay, sorry. Scratch, I can do better. Okay, so let me start again on this matrix. Here I go. Look at this matrix, and in your mind's eye, set lambda to 0 and k to 0. Okay, so now what you should see is a diagonal matrix. It's on the top left, you get omega I. On the bottom right, you get alpha I. And on the off diagonal, you get zeros. So that will give you an idea of this coordination game. And why do you get this coordination game? Because why do you get zeros off the diagonal? Because lambda is 0, and because I set k equal to 0. Okay, so if we have that, then we have a game where it's a pure coordination game, where the incumbent, if the incumbent is replaced, the only thing that matters is the promise of the incumbent, and then the citizen wants to support the challenger because that's the promise that's relevant then. And if the incumbent survives, then the only promise that's relevant is the incumbent, and then the citizen wants to support the incumbent. Okay, so this is all like I messed up the exposition, but what I wanted to have an idea is that this is a diagonal matrix with 0 off diagonal. Okay, so now let me be a little less blunt and say that first, let's make k not equal to 0. What does this mean? This means that the first row is penalized. Supporting the challenger is penalized. So therefore, k represents that if you go and protest against the incumbent, then you get beat over the head. That's a cost, and that's why k is there. K represents an element of asymmetry that favors the incumbent. And then if lambda is greater than 0, this means that the expropriation of the people who fail to support the winner is not as extreme, as is not total. But other than that, what you want to keep in mind is that, or in your mind's eye, is that this is more or less a diagonal matrix. There's an element of coordination here. All right, now the timeline. In stage 1, politicians make promises. They give a promise alpha, the incumbent gives a promise alpha to every person, the challenger gives a promise alpha to every person. And they seek to minimize or maximize the probability of incumbent replacement. So they're office motivated only. The politicians are. In stage 2, theta is realized. And after seeing a signal about theta, citizens take action. And they choose whether to support the challenger or to support the incumbent. If they support the challenger, meaning they go on the street and they protest, then they pay a cost K right off the bat. Abstention here is treated as support for the incumbent for simplicity. So if you abstain and you don't go on the street, that's kind of like supporting the incumbent as I think of it, or for the purpose of this model. And then, as I said, in stage 3, there's a regime change. The incumbent is replaced if the support for the challenger is sufficiently large based on the random variable.
Yeah, so Nicola, on that, there's a question from before, but it links to what you just said. What about, it relates to the observability of the support. And Michele Valsecchi is asking, suppose, the candidate knows if you supported him, but doesn't know if you supported the opponent. So everybody just observe that whether people supported them, but doesn't know what the others do. I guess you're saying we don't have abstention here.
Yeah, I think it's an interesting variant of the model that I haven't thought about, but it's perfectly worth thinking about.
Yeah. So should I think about these to get observability? You'd need either people to be, prominent, and so if I'm a prominent leader or so, then it's observable if I support you, or maybe a group, a class, like a union or something. So I should think of it that way.
I do. Yeah, I think of it exactly that way, Elias. Thank you. All right. So now, how do citizens make their choice? this is some importing technology from global games here. First, theta is realized. These are the accidents that make a regime vulnerable or not. Then, citizen I chooses its action, his or her action based on a private signal of this theta. So they know this theta almost exactly. Okay, this is just from global games. So it's theta plus noise, and the noise will be very close to 0. And so in equilibrium, citizens will choose to support the challenger S equal 1 if the signal, if the theta is large enough, which means if they have a very good signal that the regime is highly vulnerable, then everybody will bandwagon and support the challenger. All right. So now I'm getting to the novel part of the paper. So far was the model, obviously. But now I want to the first thing I need to do is talk about the subgame, where the promises have been made by these politicians, the alphas and omegas have been set, and then theta is realized, then citizens decide on whom should they coordinate. Should they coordinate on the incumbent, or should they coordinate on the challenger? And I want to study that subgame, which takes place for given distribution of alphas and omegas. This is a complex distribution. Okay, so for every distribution of alphas and omegas, I have to solve this subgame, which is a global game. And the outcome in the global game will depend on the distribution of alpha and omega. I'm going to, fortunately, I'm going to be able to rely on existing results that say that that talk about asymmetric global games. And this is a paper on the AER by Sakovics and Steiner that tells you, given any asymmetric global game, what the equilibrium behavior is in that game. And this is equation 1. And the equilibrium behavior is, don't read the equation yet because it's complex. So listen to my words so far, listen to my words for now. So all citizens support the challenger if the random variable is bigger, that is, the theta is bigger, if the vulnerability, the realized vulnerability is sufficiently high. And what does sufficiently high mean? It's higher than an index, which is formed based on the entire distribution of alphas and the entire distribution of omegas. Well, okay. So now what is the index? The index is what you see on the right-hand side of equation 1. What you see there is an index, is a number that is formed by summing, integrating the alphas and the omegas. Okay, so this we get from the existing literature. So what does, okay, so let me leave it at that. So what this means is that ex ante, the challenger is going to want to maximize the probability that this equation 1 is true. And that means maximizing the right-hand side of it, because you have because of the sign of the inequality. You want if you want this equation to be true, which is replace the challenger, you want the right-hand side to be as large as possible. If you want this equation to be false, then you want this to be as small as possible. So the challenger will solve to maximize the right-hand side, and the incumbent will choose alphas to minimize the right-hand side. Okay, so this is now the novelty of this paper. Existing literature does not ask the question, how do you distribute resources to win the coordination game? I do. This is the paper. Okay, so I want to stop here, that you absorb what the incremental innovation here with respect to existing literature. The incremental innovation is that I'm going to have the alphas and omegas endogenous, chosen strategically by these two politicians. If you absorb that, you're doing great. And then I will call your attention to an additional ancillary point, less important, but also important. And this is that equation 1 describes the behavior for all citizens. And what you see on the right-hand side, it doesn't depend on any particular citizen's promise. It depends on the sum of all the promises. And this is interesting because it tells you that citizens in this game reason in a way that is completely different from normal voting games. In a normal voting game, a citizen will take into consideration the how much do I get promised by one, how much do I get promised by the other candidate, and compare. In this game, not so. In this game, all citizens take a look at the index formed on the right-hand side of equation 1. And that index is the same for all citizens. What's going on? What's going on is that citizens here are basing the decisions over whom to support based on a collective perception of regime stability. And that regime stability is a function of the distribution of resources. I'm going to say it again. A citizen in this game does not think, how much am I getting? A citizen thinks, how likely is it that given what the incumbent is distributing to everyone, how likely is it that the incumbent stays in power? And I will base my decision over whom to support based on that, because I want to support the winner. Because if I don't, the winner is going to punish me. So that's the logic. As I say, very different from normal voting games. Okay. Now I'm going to talk a little bit about this objective function, which is new in the literature. And again, to simplify in your mind's eye, I'm going to ask you to set k equal to 0. And if you do, then what you see is that the indicator function is always 1, because the inequality is always true, and the k at the numerator disappears. And what do we have? We have a sum, an integral, of Talloc contest functions. The Talloc contests are an old thing in economics, or political science also. And why are they popular? Because they have nice convexity properties, that this animal here, this index, is convex in alphas and concave in omega, which is great. Because remember, alpha is what the incumbent is choosing. The incumbent wants to minimize. And so the incumbent is minimize a convex function. And the challenger wants to maximize. And behold, it's a concave function. So this is a well-behaved problem. It's not an extremal problem, it's an interior problem because of concavity, and it's symmetric. So what do we have? We have maximization of a concave symmetric function under a linear constraint. And, on the other hand, minimization of a convex symmetric function with a linear constraint. The linear constraint is the sum equal to b. And so what do you get? You get equal treatment. The optimal, the best response is, not the best response, the equilibrium is equal treatment. And so therefore, in equilibrium, everybody gets treated the same, at least for small k. So this is the big result here in the paper, the kind of the foundational thing. So if
and Nicola, one question is that I wanted then, so that's the maximization, that's the way the equilibrium looks like. And then what's the outcome of the election?
Absolutely. So the outcome of the election, recall, great point. First, great question. Let me in pieces. First, is not an election. It's a contest, right? Because the way to think about this is kind of a revolution of some kind or something like that. Okay, so aside from that, it depends on theta. So if theta is low, nothing happens. And you will not see anything going on. Nobody's going to be in the streets, and the regime is going to continue as usual. You will not see a sign of this underground competition, yeah. But if theta is large, then everybody, boom, they will coordinate on the challenger, and then you will see people on the street, and the revolt will be successful for sure in the model. Did I answer the question?
Yeah, so in the end, everybody coordinates in one
Perfectly.
action, and there's
Yes.
no it originates.
There's no miscoordination. Yeah. This is a simple, very, very stylized model in many ways. This is one of the ways. But I think an interesting feature of the model is that you can have hidden competition, that you can see, you can have threats that are unrealized, and you wouldn't know it from looking at observables. All right, so now the formal theorem, equilibrium promises. Remember I said this is a model where resource distribution will tend to be equal. This theorem makes this point, that if lambda is smaller than 1, there is a unique equilibrium in symmetric strategy, and it has the following features. First, the incumbent treats all citizens equally. No matter the lambda, everybody gets the same. And the challenger treats citizens equally if and only if k is smaller than a certain threshold. So if k is small, remember k was the thing that interfered with concavity. You remember I set it to 0? Okay, so that's why you get this thing. So if k is small enough, then the thing is concave for the purpose of the game. And so then you get equal treatment even by the challenger. But if k is large, then the challenger is so disadvantaged that they have to focus their resources on a few people. I call them the revolutionary vanguard. This is a kind of a fancy name, but the point is, why? Because the challenger has to promise enough that they have to motivate people to go on the street and be beat on the head. And if being beaten on the head is very costly, then you've got to promise a lot of resources for people to overcome this. And that may lead you to having to promise 0 to the rest. This is not obvious, once again, but it just so happens that this is where the concavity breaks. All right. So what is the novel implication of this model, of this way of thinking that I described to you? This is really a kind of a different angle. I don't want to be now, pompous, but a little bit I will be. That this is a little bit different way of looking at political economy in terms of, if you think about allocation of resources. Of course, as I said, the idea of coordination of violent overthrows is not new in political science and so forth. But connecting this with resource allocation and resource distribution, I think, is new. And so once you take that angle there, you have a kind of a novel implication, and that is that the ability to coordinate matters for resource distribution. What I mean by that is citizens who have greater or lower ability to coordinate will get more or less. And this model allows you to talk about that. So let me make this point now. Let's expand the model, generalize the model, so that a fraction of the citizens don't observe the signal about theta. You remember I said all the citizens observe theta, a signal about theta, but now a fraction of them don't. And the question is, how much will they get in equilibrium? And now I have to make an additional assumption. And the additional assumption is that the distribution of theta is sufficiently advantageous to the incumbent. Okay, so what does this mean? Remember that I talked about global games, and I said theta is something that arises in global games. Okay, now let me talk a little bit about theta. The distribution of theta in global games doesn't matter, at least the support of it. Let's say, exaggerate, the distribution of theta doesn't matter. It doesn't matter strategically in the sense that if you go back to the index that I described, you remember the integral of the Tulloch things, the distribution of theta didn't show up there. And that means that strategically it doesn't matter. And the reason that it doesn't matter in global games is that in global games, people don't act based on the prior of theta. They act based on a very precise signal about what theta is. So the exact prior distribution doesn't matter. But now here, when some citizens don't observe a signal about theta, they're going to care about the prior distribution of theta. And that's different from global games. So now the distribution of theta matters strategically. And moreover, now the distribution of theta also always mattered, even in global games, in terms of payoffs, that the distribution of theta, it could be that theta is very advantageous for the incumbent, meaning that theta is very likely very low. And if theta is very likely very low, the incumbent is almost never vulnerable, right? As I said, in the global game, it doesn't matter strategically for what people do, but it matters for payoff. It matters for how often the incumbent is replaced. Okay, here it's going to matter strategically too, because of the presence of these guys that have to go based on theta's prior, because they have no information about what the realization of it. Garance, come in, please.
So the fact, if you have a non-negligible mass of citizens who don't observe the signal, then whether they coordinate or they don't coordinate, like, do you still get how does it work for the global game and the threshold for the people who get the signal? How do you deal with that mass of uninformed
Absolutely.
citizens?
Great question, Garance. And the answer is under suitable assumptions, that is that they're not, these people, uninformed people are not too many. It doesn't change.
Okay, okay, I see.
If you, for the experts on global games, and maybe you are one, Garance, the reason
I don't know, but
okay, then I'm going to skip. I'm going to skip the reason. But the reason.
No, continue. I just mean I'm not an expert, but I know the proof in detail, and I know how it works. So I'm curious.
The global these people, these uninformed people. So here's the way to think about this: uninformed people, their action cannot depend on the realization of theta. So it's fixed from the beginning of time. And so that's just, if their action is fixed, that's just a horizontal shift in the distribution of theta.
Oh, I see.
And I just said that the distribution of theta doesn't matter in global games. So that's why, kind of more or less. It's just essentially a normalization, a horizontal normalization, additive normalization.
Thank you.
Thank you, Garance. So, all right. Okay, so under the assumptions that I described, meaning that, so if the incumbent is sufficiently advantaged, empirically what this means is the incumbent has lived a long time, has been incumbent a long time. This is how you would convince yourself that the incumbent was advantaged. Then these citizens that don't have the ability to coordinate receive 0 from both politicians. And the intuition is that given that there's a K, that there's a threat from supporting the incumbent, the challenger, that you get beat over the head if you protest. These citizens, they think it's unlikely that they don't know what theta is, right? The informed citizens know and they can coordinate, but the uninformed don't. And they think ex ante it's unlikely that any protest is ever going to succeed. So therefore, I'm not going to protest. All right, so the implication here is that citizens with greater ability to coordinate with others get more. And this is new to my knowledge in political economy. What is the ability to coordinate in the real world? In the real world, it's having access to a public signal of regime vulnerability, such as you may get from social media. Like these revolutions in the Middle East, what do you call them? The Arab Spring. These people say that they're due to the internet, and of course, we understand that the internet matters. So for coordination, so that's my point. When the internet comes in, a lot more people can coordinate a lot more quickly from a political perspective. Also, physical closeness. Traditionally in history, and even today in developing countries especially, urban dwellers are thought to be more easily coordinated than farmers that live in the countryside. Similarly, members of the military are thought to be easier to coordinate because they all live in the barracks, they all live together. And so these would be examples. This idea about urban dwellers that I mentioned connects to a development literature that argues. This is Bob Bass, has a book called Market and States in Tropical Africa, and a big point is that the democracy, when a system is democratic, it helps farmers because voting obviates for the need to coordinate. Instead of coordinate, you can vote. And in a democracy, that's good enough. But in a non-democracy, you need to coordinate and that's harder for farmers. So that's his point. So he goes through, this is a big book, so it's a big case studies of the industrial policy and how it tariffs and how they favor urban versus rural. But that's the underlying mechanism, and so this model gives some voice to that, formal voice to that idea. All right, now let me, I want to compare with anonymous voting, because after all, anonymous voting is 99% of the political economy literature. Okay, so anonymous voting is a special case of this model, and this is when K is equal to 0, so you don't get beat over the head if you vote for the challenger because voting is anonymous, and you don't get penalized if you voted for the wrong guy, for the loser, because again, no one knows whether you vote for the loser. Okay, with that in mind, what you see here in this matrix is the payoff matrix, is the same payoff matrix that I showed before, except K has been set equal to 0 and lambda has been set equal to 1. And the moment I set lambda equal to 1, you see this is no longer a coordination game. You don't have off-diagonal zeros. You don't even have off-diagonal smalls. You have off-diagonal big. And in particular, what you see is that if you fix on a column, if you fix your attention on a single column, it doesn't matter to the citizen whether they vote for the challenger or for the incumbent. This is we know this from it's called I think Downs paradox. But the idea is that in an election, what you vote individually doesn't matter. You know, your vote doesn't matter individually. This payoff matrix expresses that idea. This payoff matrix is exactly the voting games as we normally do them. That your payoff depends on who gets elected and what they promised you, but not on what you do. Okay. Of course, Downs paradox requires taking a stand on how people vote. If a vote doesn't matter, I'm going to take their stand, the standard stand, and that is that citizens follow their dominant strategy. They vote for the challenger if and only if the challenger promises more than the incumbent. This is called pivotal behavior. If I did anything else, you'd be mad at me and you would be right. So I'm going to make this assumption. And the point why I'm making this assumption is because I want to write the payoff function from the perspective of a candidate, of a politician. And here it is. You see this equation here. This is from the point of view of the challenger. The challenger chooses how to allocate resources omega so as to maximize the number of voters where the challenger offers them more than the incumbent. So these are the people that's the vote share for the incumbent. And the reason that I'm writing this objective function is to contrast it with the previous one that I showed you. If you remember the previous one, it was very different. It was an integral of Tulloch. It was omega divided alpha plus omega. But this is very different. That was concave in omega. This is not. How do you know? Well, for given alpha, if you move omega, and if omega is small, the indicator is false. so it's 0. And then as you grow, and then the indicator becomes true and it jumps to 1. So you have a step function. You have the sum of step functions, and a step function is not concave nor convex. This is why voting in a democracy, so you don't have the same concavity property. That's what I'm trying to get at, that you have dominant strategy here in voting. People vote for the person that gives them the most, but the resulting payoff function for politicians is not concave. And that's why in democracy, there is the possibility of having these smaller coalitions. Not everybody gets treated the same. There is democracy is a lot more volatile in this respect, in the sense of coalitions. There is no tendency to universalistic coalitions in a democracy. Not everybody needs to get treated the same. It depends on the assumptions of the models that you then put on top. But what you see here is kind of the basic problem in a mathematically problem that you don't have concavity. Okay, so now with that, let me make a contrast with anonymous voting games. This is Lindbeck and Weibel's famous model of distributive politics. Meyerson, slightly less famous, but also famous model of distributive politics. So I'm making a comparison between what political economy has to say so far about distributive games and what I have to say. Okay, so in anonymous voting, that is the traditional political economy, citizens allocate their support based on the individual promise they receive. Politicians receive 50% of the vote. Whether citizens are treated similarly or dissimilarly by candidates depends on the ancillary assumptions of the model. In the Meyerson model, citizens are treated differently due to that non-concavity that I described. In the Lindbeck and Weibel model, citizens are treated equally. And that's because Lindbeck and Weibel put on additional assumptions to ensure concavity. My take on this is that it depends on the details of the model. Finally, in these models, in anonymous voting, in traditional political economy, the citizen's ability to coordinate doesn't matter because the voting process is the coordination mechanism. Conversely, in the model I present today, citizens allocate their support based on the collective perception of regime stability, not on what they are promised, but when everybody is promised. Politicians receive either 0 or 100% of the support. This is because of perfect coordination. There is a tendency towards equal treatment of similarly situated citizens. And by similarly situated, I mean that have the same ability to coordinate. People who have the ability, so in other words, who gets more, who gets less depends on their ability to coordinate. That's not the case in anonymous voting, where the citizen's ability to coordinate doesn't matter. So this is the basic distinction here. All right, now 2 illustrative applications. These are not meant to be historical case studies, obviously, in 1 page and 1 minute, but rather an idea of how you would map the elements, the primitives of the model I showed you into reality. What would you look at? Okay, so Russia 1914. There's a czar, and the czar has a model of development that is authoritarian capitalism, I'm going to call it. And this model favors city dwellers and connected insiders, people who own factories, maybe big landlords, things like that. But 90% of the population is farmers. They are dispersed and they are unable to coordinate. That creates no problem politically until there's World War I. And World War I implies conscription. So a lot of young men are in the army, they gain the ability to coordinate. This is true throughout history. Whenever an army is formed, there's danger as much as for the owner of the army as much as for the other party, and sometimes more. So anyway, okay, so this being the situation, there's an alternative. There's Lenin's egalitarian development model, and that model momentarily fits better the set of the people who have the opportunity to coordinate, the set of people who have the opportunity to coordinate. What do I mean by that? All of a sudden you have the farmers. Previously they couldn't coordinate, but now they're in the army, they can coordinate. And of course they're organizers, right? The communist organizers in the factories, in the army. And so that means that an egalitarian development model now is better in the moment. And so there's a revolution, the revolution is successful. Okay, so this is a simple mapping. Now I want to add a little more that's not required but I think is interesting. That in the particular event of history in 1917, etc., Lenin's model was aimed at collectivization of agriculture and industrialization. That was the way of developing. And what do these things mean for coordination? They increase coordination because in a factory, everybody is together, and in a collective farm, everybody is together also. So all of a sudden, this is a development model that requires more coordination, and that has political implications. In particular, the implication is that it's a form of political commitment to equal rents, because if everybody can coordinate, everybody gets rents, even in an autocracy. Okay. Second, illustrative application, contemporary China. And I want to talk about the importance of social media. Social media, as I argued, increased the ability for the population to coordinate, even though it's managed. Of course, in China, it's managed. But nevertheless, the net effect is to increase the population's ability to coordinate. And so as a result, you get, in my reading, you get Xi's common prosperity drive to reduce income inequality. This is a drive that stigmatizes conspicuous consumption by celebrities. It bans private tutoring that is used by the elites and curbs real estate speculators. In general, there's this rhetoric of equality that you didn't hear before as much. And you don't hear in democracies as much either, I would say. That's my perception, at least. It's subjective. So in conclusion, I offered a model for thinking about policy selection when political action is individually incentivized. The regime type is characterized by two parameters, political liberties and individual liberties, as well as the ability to coordinate, I should have added. And coordination matters for allocation. That's a new implication. In regimes with where lambda is less than 1, so this means political activity is contractible, political incentives push toward egalitarianism among those with the power to coordinate. But when lambda is equal to 1, meaning anonymous voting, democratic political economy, you don't get that push. You don't naturally get that push towards egalitarianism. You can get it in models if you add more ingredients, but it doesn't naturally lead there. And so that's my story. Thank you for your time and for being here.
Thank you, Nicola. I saw you had still many slides there, so there were some questions that weren't clarifying that I didn't take right there, and then I'll open the floor for, we'll have more time now for discussion. I have one initial question. So you seem to be talking about elections, but then it seems also to be a model of protests in a sense, and I think you want to have a model of everything, of both, in a sense. And so I guess when K is 0 and lambda is 1 is forcibly an election you're talking about, but then when K is positive, then it starts looking more like a model of a protest. And definitely when lambda is less than 1, it's, you have a sense when, it'd be nice to have a sense, when are you talking about an election and when are you talking about a protest? A protest is obviously something you can observe more clearly than a vote. So I don't know if you have a sense of, is that right, that you want to have a model of that encompasses all these situations?
Yeah, so maybe the way to understand the way I'm hearing the question is, as K and lambda converge to democracy, to anonymous democracy, etc., how does the allocation change?
No, so I think you have I think when is it that you're talking? When is it that it is a model of a protest? There's models of protest there, of revolutions that have this coordination aspect, I guess, there. And then you look at this.
Yeah. So once again, the point is the novelty here is, what does it imply for the allocation of resources?
Right. But then it becomes a model of elections only when you think about this being a model of elections.
Yeah, when K
lambda
is equal to
1.
0 and lambda is equal to 1.
Okay, and then everywhere else is more a model
Everything
of a protest?
else, yes. Although I'm not too keen on some people, not me, might take great joy in taking these limits and showing some discontinuity or continuity. That's not me. I'm happy to think about large K, small lambda, autocracy, and K equal 0, lambda equal 1, democracy. I'm not, me, Nicola, too excited about limits, even though I see the value of them.
Although you have a nice result that as long as lambda is not strictly 1, the things change radically, right? So you have a nice...
Yes, absolutely. Oh, I see what you're saying. Yes. Yeah. I think to me, an exciting new or extension of this or new thing would be, like you said, I mean, in many environments, in many countries, in many political systems, you have both elections, and so anonymous voting, and also political activity that is observable by elites and so forth, like Twitter, and things of that nature. And having the two together, how much resources to one, how much to the other, would be very interesting and probably next on the agenda.
Thank you, Nicola, for this very interesting theory of everything, exactly. So I like that you referred to a couple of examples in China and Russia, and I guess my question is, why did the Tsar have this strange authoritarian capitalism model? Why didn't the Tsar understand that he will be very easy to unseat? So do we think that the Tsar's prior on distribution of theta was wrong, or the Tsar had the right ex ante perceived distribution but got unlucky because of the war, for example? But then again, going to war was a choice. Russia didn't have to go to war. So why do these incumbents occasionally make such stupid mistakes? Because in the slide you gave, it looks like the Tsar is not strategic. He just makes this choice and gets kicked out. And this is, I guess, is related to these ideas of democratizations by mistake, where when incumbents just have wrong ideas or make mistakes, stuff like that. So how do we think about this?
No, Sergey, I think I have more to learn from you than I can teach you on this. So I think of this as I think in reality that there's many. We all know from history that I think we can say that hopefully nobody takes offense here, that the Tsar's family, just the historical, everything that we know historically about them was not hyper rational, right? So I wouldn't certainly discount the idea that, okay, so that's one aspect. The other aspect is that all the Tsar's friends and tradition, etc., these are the nobles, they want authoritarian capitalism. So it's not my place, nor do I have the time to go into the details, but we know from all sorts of institutions that we know well that institutions are dysfunctional. So and then you put in luck and wars. I mean, anything could happen. So that's my take.
basically, we understand that he was unlucky. He had wrong views. I'm just trying to connect what you just said to your model, to theta, to the distribution of theta.
The model is a model of luck because theta is random. So you could take bad policies and be lucky with the theta many times in a row. Yeah.
Yes, thanks. Garance, please.
I was curious, thinking about the incentive to, if you think that the incumbent can control the level of information or who gets the signal, or is there a tendency for like bang bang, that if the prior seems good for him, then he wants to suppress all information, while if the prior seems to be bad for him, then he would want actually people to get the information.
Thank you, Garance. It's a great question, and it tells me that I have one more thing to think about. I don't have an answer right off the bat. Certainly, it's very natural. It's very natural to think along these lines, but I don't have an answer yet. Thank you.
Thank you.
Tom Romer.
Hi, Nicola. How are you?
Hey,
good
Tom.
Good to hear the progress of this project. I think we talked briefly about it some months ago.
Yes.
You seem to give us kind of stylized examples, regime transitions, as you did here. Could you make regime comparisons yet? You sort of imply that democratic societies are going to have much more unequal policies than authoritarian societies. So if you did that comparison rather than the regime transition, are you confident that that's an empirical, even stylized fact?
No,
or do you disagree with my characterization of your results? Wrong?
Yeah. So what that's a question that I struggle with. I have other implications that I think are more directly, testable, but the general question of inequality, I think, is confounded by the question of levels of wealth, and it's difficult to, I think, empirically.
I'm not talking about economic inequality, but rather distributive policy that's more equal in one set of regimes versus the other. I'm not talking about levels.
I see what you're saying. Whether
the pattern of policy that you seem to highlight a lot in your model.
Yes, I see what you're saying. So the way that government intervenes in the economy is to equalize more or equalize less.
Yes.
That's a great question. I'll think about it. What I seem to see is rhetoric in more autocratic regimes that is of a more egalitarian nature. But this may be just the ability to control the media more. So I don't know exactly.
You also have an implication about what might be kind of sort of patronage politics, right? In one regime versus another, right? And sort of the direct appeals to specific groups. So obviously your model's going there.
Yes. There are many areas of contact with reality, and I still have to wrap my head around all of them.
I guess that seems like a more natural and easier set of comparisons than regime transitions, in which you raise all of these historical dynamics that Sergei alluded to are very confounding.
I'm sorry, Tom, I cannot hear well what you just said. Can you repeat?
We can take this offline or some later. I don't want to take up other people's time, so just let's postpone.
No, go ahead, Tom. There's not many questions online, so please go ahead.
Yeah. So on regime transitions, can you say something about ex-ante welfare between the two types of regimes that the two extreme regimes that you discussed? Like, as ex ante, as a voter, would I prefer to be in one or the other, conditional on some set of fixed parameters?
Okay, so yeah, so let me two things. By regime transition, you mean that
or even ex ante welfare as a voter? Am I better off under one?
Yes. Okay.
Than the other? Would I rather be in the anonymous voting system or in the?
Yeah. Okay. Got it. Yeah. So I think so. Here's my take. So the answer depends on the technological opportunities that are available. So I think of this model, even though it's very abstract, in my mind's eye, this is a model about industrial policy. And so I know that the jump is a little bit weird here, but so if you are a country that is lagging behind, then I think it may the autocratic regime has proved historically that sometimes it can lead to relatively fast development. If you are a country on the technological frontier, they're all democracies. So the implication here is that a model that a regime, now coming to my paper, a regime that is non-democratic is going to reward policies that give industrial policies that lead to more equal allocation. And you can get these industrial policies when you're behind the frontier by importing technological knowledge from abroad. So the idea is that if you are a country on the technological frontier like the US, then you have to reward innovation. And that reward creates inequality. And that inequality, especially among the elites, is going to get punished in is not going to be helpful to an autocrat. But if you're a democracy, that inequality that permits or encourages technological innovation is acceptable, is more acceptable. That's my take. I know it's a big leap, but since you asked, here it is.
Thank you for a great talk. I was just wondering, like, there is the assumption that the promises are credible and enforceable. And I'm thinking, yeah, is it possible to discuss what may happen if these assumptions do not hold?
Yeah, no, that's a great question. This is a question that kind of divides. It's a cleavage in political economy where you have prospective voting or retrospective voting. That there are some models in political economy where you don't reward the promise, you reward the performance. And that would be also very interesting to to study. I think it's probably both, but I would all of distributed politics that I know is done with prospective voting, meaning the way I'm doing it here, credible promises. And so it would seem a more direct avenue for comparison, but maybe that there's an equal amount of work to be done in the other field too. So Ali, thank you. I don't have much else to say.
Thank you for the question, Ali. I'm sorry I couldn't see your hands raised on the system, so I didn't call you. Apologies.
No worries.
I couldn't see it. I guess we have no more questions, and we're almost out of time anyway. So thank you very much, Nicola, for being part of our series. And we'll resume in a month on the first Wednesday of April at 3 p.m. London time with Roman Vaxiarg as our speaker. Thank you very much, everybody, and see you next month.